some function and trying to figure out where the original function was to get this derivative here. So basically we want to make sure we know our power rule first of all, which we went over the last class, but we also want to know our standard integrals or standard derivatives. So derivative of cos is sine, so the antiderivative of derivative of cos is negative sine, so the antiderivative of sine is negative cos. I put the k in there because when we differentiate, we need to multiply by k, which gets rid of that k. So when we have the k here and we're going backwards, we need to make sure we divide by that k so that we account for that extra coefficient. So the derivative of sine is cos, so the integral of cos is sine. The derivative of tan is secant squared, so when we see secant squared, we can anti-differentiate to tan. Derivative of e is e, so we go backwards, we can just get e. The derivative of log is 1 over x, so the antiderivative is log. And then we also have our exponential function here. It's the same, except when we differentiate this, we're going to times by log a. So when we integrate this, we divide by log a. So based on these known antiderivatives, we can just anti-differentiate these expressions. So the integral of this is going to be negative cosine 3x. We need to make sure we account for that extra coefficient of times 3. And then we're going to have a plus c because we don't know if there was a constant value that was there in the original function. So here the antiderivative is going to be sine. Okay, so the derivative of sine is cos, so the antiderivative of cos is sine. And again, we have to account for that times 3 by dividing by 3. And we also need to have a plus c involved in there. So the exponent, the antiderivative is itself. Okay, since we would multiply by log 3, we need to divide by log 3 when we go the other way around. Okay, and then we need a plus c here. So we've got a bunch going on here. We've got power rule, so it's going to be 2x to the power 5. We need to divide by 5 to account for that extra when we bring the power down. E is going to be itself, but that extra times 3 from chain rule, we've got to account for that. The 4 is a constant, so that must have been a linear function 4x. And we also have to have a plus c that we have to account for. So this one here, we can just use power rule. So we're going to apply power rule to 1 over x squared. So basically it's going to be the derivative of 1 over x. That negative 1 power will differentiate to negative 2. So the antiderivative should be 1 over x. Okay. But we have to account for that extra negative in there. So maybe I'll just do this with a negative exponent. Okay, so this anti-differentiates to x to the power negative 1, and then we have to divide by that negative 1, and then we have a plus c, so it's going to be negative 1 over x plus c. Okay, so the derivative of 1 over x is negative 1 over x is going to give us positive 1 over x squared. So there is our antiderivative. Here we can again apply power rule. It's going to be negative 2x. Increase the power by 1, so we're going to get negative 1/3. And then we're going to divide by the power negative 1/3 because we're applying power rule. Minus. Okay, this is an exponent, so it's going to be just itself. Okay, except we have that extra times by negative 1, which we have to account for. And then the 1 over x, well, 1 over x is a special one. We're going to take a little bit closer look at that. But 1 over x, we have to remember, was the derivative of log x, and then plus c. And we should really simplify this a little bit. So this is going to simplify to positive 6x to the negative 1/3. This is going to be positive 3 negative x plus 2, and this is going to be minus log x plus c. Okay, and again, this one here is just going to be straight power rule. So we're going to get negative x to the power 5 divided by 5 minus, this is going to be x to the negative 2 divided by negative 2. This is going to be, start with negative 1/2. We're going to end up with positive 1/2. And again, we divide by the 1/2 plus c. We clean up these negatives and everything a little bit. We're going to end up with negative, this will be positive 1 over x squared times 2 on the bottom. This is going to be minus, the 2 is going to go on top, and square root x plus c. Okay, so that represents the antiderivative of that function.